Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about IPv4 and IPv6 header format. In previous session, already we discussed about IP addressing. What is IP addressing? How we have to give the classes. What are the rules we have to follow for giving the IP addresses? All we have discussed in previous class. Now we are moving into the IPv4 and IPv6 version 4 and version 6. First, let us see the overview of today's session. First, we have to discuss about IPv4 header format. How we have to give the version 4 format, and next we have to discuss about IPv4 datagram header. And next we have to see the differences between IPv4 header format as well as the IPv6 header format, that is version 6. So first let us see what is IPv4 datagram header format. See in this, first of all, IPv4 Internet Protocol version 4. IP stands for what? Internet Protocol. V4 stands for version 4. So it is mainly used for routing the internet traffic. At the same time, and other packet switched layer networks, we are going to use this IPv4. This is called as the Ethernet. In Ethernet connections, we are going to use the IPv4 format. So it is the first version of the satellite, and it is in the 1982. This is the satellite network. At the same time, ARPANET that is going to be used in the 1983, that is Advanced Research Project Agency Network. This can be used in this particular year, that is 1982 and 1983. So it is a 32-bit address. IPv4 is mainly having the 32-bit address. At the same time, it is organized into the 4 octets. In previous class already we discussed total how many octets are there? 4 octets, x dot x dot x dot x. Total 4 octets are there. Each octet is having how many bits? This is 8, this is 8, and this is 8, this is 8. Total how many is it is having? Total 32 bits. 4 octets and 8 bits for each one. Total is 32. 4 into 8, 32. Which this can be used using the dotted decimals. That is, like this we have to write. We have to write the range of the IPv4 address. Means whatever we are writing, that is numeric form only. Whatever address we are writing, whatever address means the range is only 0 to 255. That's why we are writing in the numerical form only. 172.140.153.12. That is the numeric form. That is suppose previously we discussed, right? What is the range of this particular this IP address? In which class this is going to be there? Class A, Class B, Class A. Already 0 to 127, that is the Class A. 128 to 192, that is Class B. And 192 to 223, that is Class C. So this is the range in Class B. This is the range of what? Class B. So it is in Class B. Like this we have to identify. Based on the numbers, based on this IP address, based on the classes already we said, based on that we have to identify the IP address in which class it is going to be there. And next one. So what is the IPv4 datagram header format? How it is going to be represented? See here, this is the IPv4 header format. See first in total it is having the total 32 bits. Total length is 32 bits. So here the fields is version field is there, header length is there, version is 4 bits and header length is 4 bits. Type of services is having the 8 bits and total length is also having the 16 bits. And next identification is having the 16 bits. It is the null bit. This is 0 means null bit. And the next one, this is 1 1, and dot fragment also 1, and more fragment also 1, and frequent total is 13. So here is 16, here is 13, 14, 15, 16. Total is 16 plus 16. Here also 32. This is also 32. Like this, each and every sequence is indicating with the 32 bits. And next, time to live is having the 8 bits. Protocol is 8 bits. Header checksum is 16 bits. And the source is having the total is 32. Destination is 32. Options, the size is 0 to 40 bytes, and finally data. This is the header format of the IPv4. Let us see one by one what is the work of each and every field. We have to see now. First one, version. What is version? Version is talking about the which version it is. That is total in IP address it is having the 2 version. That is the version 4 is there, version 6 is there. Which version it is? Means it is the 4th version, that is the V4 protocol, which is the 4 version 4. So that's why it is version 4. It is having the 4. At the same time, header length. What is the header length here? Header length is having how many bits? Total is 4 bits only. At the same time, it is talking about the length of the header. What is the length of that particular header? It is knowing from what exactly it is saying the header length is, where the actual data begins. Header length is mainly talking about from where the actual data is going to be begin, at the same time how long the header is going to be there. That is talking about the header length. It is in between 0 to 20 to 60 bytes. The type of service. Type of service is talking about it is how many bits? 8 bits. At the same time, it is talking about the which service it is going to be provided, means based on the low delay, high throughput, reliability are the type of services. Which types of services the IPv4 is going to be provided. So, this field is used for the quality of the service. What is the quality of that particular IPv4 header format? That is the quality of that particular service. Means delay is low, the sender throughput is high, and reliability also important whenever we are sending the packets from source to destination. That's why it is providing the services. And the next one is the total length. Total length is talking about, it is the 16-bit field. It is the 16-bit field. It is talking about the length of the total IP packet, including the IP header as well as the payload. See here, total length is talking about the header length as well as the payload length. Payload length means the total length only, but excluding the header. Payload is talking about the how many packets are going to be transmitted. That is the payload. And the header is we are not including in the payload field. That's why we are writing with the header. So that's why it is the total length. Identification is talking about to identify the fragments in the original IP diagram. We are going to use the identification. That is the 16 bits. And next one, DF. That is nothing but the don't fragment. That is talking about the, if it is a 1-bit field, it is having only 1 bit. At the same time, if it is going to be allocated 0 or 1, it is going to be allocated 0 or 1. If it is set to 0, suppose it is set to 0, it allows intermediate device to fragment the datagram if it is necessary. That is, if we set to 0. And if it is set to 1, it mainly instructs the intermediate device to avoid the IP datagraphs. We are going to use the set. If it is set to 1, to intermediate node, to avoid the IP datagraphs, we are going to use. And next one is the more fragment bit. More fragment bit mainly used for, it is also having only 1 bit. Mainly it is talking about it is also 0 or 1. This value also 0 or 1. So if it is set to 0, what it will do? It indicates the receiver the current datagram is either the final fragment of the or the only fragment we have to say. And if it is set to 1, it indicates the receiver that the current datagram is fragment of some larger datagram. That we have to know about the if it is set to 0 or 1. And coming to fragment offset. Fragment offset is having the how many bits? Total is 13 bits. So it tells the exact position of the fragmented datagram. What is the exact position of the datagram in the original unfragmented IP datagram? We are going to say. That is about fragment offset. And next, time to live. Time to live is total is having the 8 bits. Here it is the time to live. It is talking about the 8 bits. It prevents the datagram from the looping over the network by reducing the number of hops of a packet can take before reaching to the destination. Means how much time the packet is going to be live. That is time to live. And next one is the protocol. Protocol is talking about 8 bits. It is talking about the network layer that a destination host, which protocol is going to be used. That is talking about the protocol. What are the protocols we are going to use to reach that particular destination? For that purpose, we are going to use the protocol. ICMP, Internet Control Message Protocol, can be used. Means suppose if you use this particular protocol, the protocol number is 1. Suppose if you use TCP, the protocol number is 6. If you use UDP, the protocol number is 17. Like that, it is indicate the which protocol is going to be used to reach the destination of that particular packets. And the next one is the header checksum. Header checksum is talking about total having the 16 bits. It is having the entire header checksum means if any errors are there, error detection, and checksum is nothing but what purpose? Error detection and error corrections. Detection and correction. We are going to use this particular header checksum. And source IP is talking about what is the source IP address. It is having the 32-bit field, the address of the sender. And destination is talking about it is also having the 32 bits, the address of the receiver. These two are the source and destination fields. And next one, options. Options can be used for the range size from 0 to 40 bytes. The range is 0 to 40 bytes. The datagram header size can vary from 20 to 60 bytes due to this particular field. This is the optional field. And finally, the data. This is about the IPv4 header format. This is null bit, this is don't fragment, this is more fragment. This is the IPv4 header format. And the next one is IPv6 datagram header. IPv6 is having total 2 parts. So it is having the header field at the same time payload field. Payload field are the saying that how many packets are going to be sent, excluding the header. It is total. But including means total means dividing header plus payload is nothing but the IPv6 also. The header of IPv6 is fixed length. Header length is 40 bytes. The same time, see here it is having the fields are version, traffic class, flow label, payload length, next header, hop limit, source and destination. This is about the IPv6. So previously it is having 32 bits only, but IPv6 it is having the 128 bit address. It is having 128 bit address. See here what are the different fields are there in the IPv6. First version is having the how many total 4 bits. And so it is talking about what it is saying, what is the version of particular protocol, that is nothing but 0110, that is the version 6. And traffic class is talking about the 8 bits. So it is talking about the, it is divided into two parts. Most significant 6 bit. It is a type of service mainly talking about the router will get to know about the what services need to provided. What are the services are going to be provided to the given packet. At the same time, it is also talking about ECN, explicit congestion notification. The least significant 2 bit is used in this traffic class, that is the 8 bits. And coming to flow label, that is 20 bits. This is the flow label, totally is having the 20 bits. See, it is mainly for maintaining the sequential flow of the packets. We are going to use the flow label. Flow is talking about the sequential flow. And the next one. So next field, there is the payload length. Payload length is talking about totally it is having the 16 bits. So it is help to router to know how much information is stored in the payload. For that purpose, we are going to use the payload length. And the next header. Next header is talking about 8 bits. It is having the 8 bits mainly for type of extension header. Or if the extension header is not present, then it shows the upper layer of PDU. It will show. Means extension of the header, it will show. That is the next header. That is having the 8 bits. And coming to hop limit. Hop limit is also 8 bits. It is talking about the hop limit, the header that stops the header from going into the infinite loop in the network. So how much time it is going to be leave. That is talking about the hop limit. When it processes to hop or router, its value is decremented by 1. And the packet is discarded when it is going to reaches to 0. If it is reaches to 0, it is going to be discarded. If it is passes to 1 by 1 router, the value is going to be decremented by 1. That is the hop limit. That is also having the 8 bits. And coming to source address, that is 128 bits. The field mainly talking about the what is the address of the source. Destination means it is talking about total is 128. In previous case in IPv4, it is having 32. It is having 32 only in IPv4. And coming to IPv6, total is what is the length here? This is the hexadecimal length. That's why it is the 128 bits. So it is also having the 128 bits. It is talking about the destination address. And next one, we have to see the differences between IPv4 and IPv6. IPv4 stands for Internet Protocol version 4. It is the protocol version 6. It is the numeric address. Whatever address we are writing to 2.123.6.75. This is the numeric address. And coming to this alphanumeric, IPv4 is having the 7A, 3B, 5C, 1D, like that it is there. That is the alphanumeric addressing. And it is consisting of the 32 bits in the form of 4 octets. And it is also consisting of 128 bits. It is 32, it is 128 bits. So in the form of 8 segments. Because it is 32, we are dividing into 4 octets. And coming to here, it is 128, that's why we are giving double, that is the 8 segments. IPv4 use the dot in between the addresses, we are using the dot symbols. And here we are using the colons to separate the addresses. And IPv4 perform the unicast, broadcast and multicast. And IPv6 performing unicast, anycast, multicast, but there is no broadcasting. IPv4 is divided into 5 classes. Class A, Class B, Class C, Class D, Class E. Like the classes are there in IPv4. And coming to class IPv6, there is no classes. We are not defining any classes in IPv6 because it is an hexadecimal address. IPv4 header is very large and consisting of the 12 fields. And this header is small. IPv6 header is small. It is having the 8 fields only. And the length of this header length of this IPv4 is 20. And header length of this field is IPv6 is 40 bytes. And IPv4 is containing the checksum field. Means here the error checksum, error correction, error detection is there. Checksum means error correction and detection. That is the checksum field is there. But IPv6 there is no checksum in the IPv6. These are some differences between IPv4 and IPv6. And coming to the summary, in this session we discussed what is IPv4 and what is the datagram header of IPv4, and next we have seen IPv6 datagram header format, and next we have seen the differences between IPv4 and IPv6 header format. Thank you.